Hi everyone, welcome to our event. This event is brought to you by DataTalks.Club, which is a community of people who love data. And we have weekly events, and today is one of such events. And I guess we are also a community of people who like to wake up early, if you're from the States, right, Christopher? Or maybe not so much,
Absolutely.
because this is the time we usually have our events. For our guests and presenters from the States, we usually do it in the evening of Berlin time, but yes, unfortunately, it kind of slipped my mind. But anyways, we have a lot of events. You can check them in the description, like there's a link. I don't think there are a lot of them right now on that link, but we will be adding more and more. I think we have like 5 or 6 interviews scheduled, so um, keep an eye on that. Do not forget to subscribe to our YouTube channel. This way you will get notified about all our future streams that will be as awesome as the one today. And of course, very important, do not forget to join our community where you can hang out with other data enthusiasts. During today's interview, you can ask any question. There is a pinned link in the live chat. So click on that link, ask your question, and we will be covering these questions during the interview. Now I will stop sharing my screen. And there is a message in Christopher, it's from you. So we actually have this on YouTube, but so they have not seen what you wrote, but there is a message to anyone who is watching this right now from Christopher saying, hello, everyone. Can I call you Chris
Okay.
or you prefer
Oh, okay. I should
Christopher?
go on. I should look on YouTube then. Okay.
Yeah. But anyways, you don't need, like, you will need to focus on answering questions, and I'll be keeping an eye on all the questions.
Okay.
So, yeah, if you're ready, we can start.
I'm ready. Yeah.
And you prefer Christopher, not Chris, right?
Chris is fine.
Chris is fine. It's a bit shorter. Okay. So this week we'll talk about DataOps again. Maybe it's a tradition that we talk about DataOps every like once per year, but we actually skipped one year. So because we haven't had Chris for some time. So today we have a very special guest, Christopher. Christopher is the co-founder, CEO, and head chef or head cook at Data Kitchen with 25 years of experience. Maybe this is outdated because probably now you have more and
Yeah.
maybe you stopped counting. I don't know, but like with tons of years of experience in analytics and software engineering, Christopher is known as the co-author of the DataOps Cookbook and DataOps Manifesto. And it's not the first time we have Christopher here on the podcast. We interviewed him 2 years ago, also about DataOps, and this one will be about DataOps. So we'll catch up and see what actually changed in these 2 years. And yeah, so welcome to the interview.
Well, thank you for having me. I'm happy to be here and talking all things related to data ops and why bother with data ops, and happy to talk about the company or what's changed, and excited.
So let's dive in. So the questions for today's interview are prepared by Johanna Bayer. As always, thanks, Johanna, for your help. So before we start with our main topic for today, DataOps, let's start with your background. Can you tell us about your career journey so far? And also for those who have not listened to the previous podcast, maybe you can
Sure.
talk about yourself. And also for those who did listen to the previous, you can also maybe give a summary of what has changed in the last 2 years.
So we'll do. Yeah. So my name's Chris. So I guess I'm a sort of an engineer. So I spent about the first 15 years of my career in software, sort of working and building some AI systems, some non-AI systems at US's NASA and MIT Lincoln Lab, and then some startups, and then Microsoft. And then about 2005, I got the data bug. I think my kids were small, and I thought, oh, this data thing was easy, and I'd be able to go home for dinner at 5, and life would be fine. Because I was a
And
big
you
software
started your own company, right?
guy. And it didn't work out that way. And what was interesting is for me, the problem wasn't doing the data. Like we had smart people who did data science and data engineering. The act of creating things, it was like the systems around the data that were hard. Um, things, it was really hard to not have errors in production. And I would sort of drive into work, and I had a BlackBerry at the time, and I would not look at my BlackBerry all morning. I had this long drive to work, and I'd sit in the parking lot and take a deep breath and look at my BlackBerry and go, "Oh, is there going to be any problems today?" And and if there wasn't, I'd walk in very happy. And if there was, I'd have to like brace myself. Um, and then the second problem is the team I worked for, we just couldn't go fast enough. The customers were super demanding. They didn't care. They always thought things should be faster, and we were always behind. And so, how do how do you live in that world where things are breaking left and right? You're terrified of making errors, and then second, you just can't go fast enough.
And
And
it's
so,
pre-Hadoop era, right? It's like before all this big data tech in
oh yeah, as
2005.
before, we were using SQL Server, and we actually, we had smart people, so we built an engine in SQL Server that made SQL Server a columnar database. So we built a columnar database inside of SQL Server. In order to make certain things fast, and yeah, it was really it's not bad. I mean, the principles are the same, right? Before Hadoop, it's still a database. There's still indexes. There's still queries, things like that. We at the time you would use OLAP engines. We didn't use those, but
Mm-hmm.
there's reports.
Mm-hmm.
R for models. It's not that different.
Mm-hmm.
Um, we had a rack of servers instead of the cloud. Um, so
Mm-hmm.
yeah, and I think so. What I took from that was uh, it's just hard to run a team of people to do data and analytics. And it's not really, I took it from a manager's perspective. I started to read Deming and think about the work that we do as a factory, and a factory that produces insight and not automobiles. And so how do you run that factory so it produces things that are of good quality? And then second, since I had come from software, I've been very influenced by the DevOps movement, how you automate deployment, how you run in an agile way, how you produce, how you change things quickly, and how you innovate. And so those two things of like running a really good solid production line that has very low errors, and then second, changing that production line at very, very often, they're kind of opposite, right? Um, and so how do you as a manager, how do you technically approach that? And then 10 years ago when we started Data Kitchen, we've always been a profitable company. And so we started off with some customers. We started building some software and realized that we couldn't work any other way, and that the way we work wasn't understood by a lot of people. So we had to write a book and a manifesto to kind of share our methods. And then so, yeah, we've been in business now about a little over 10 years.
Oh, that's cool. And like what? So let's talk about DataOps. And you mentioned DevOps and how you were inspired by that. And by the way, like, do you remember roughly when DevOps as a thing started to appear? Like, when did people start calling these principles and like tools around them as
Yeah,
DevOps?
yeah. So the Agile Manifesto, well, first of all, I had a boss in 1990 at NASA who had this idea: build a little, test a little, learn a lot. Right? That was his mantra. And then, which made a lot of sense. And then the sort of Agile Software Manifesto came out, which is very similar in 2001. And then the sort of first real DevOps was a guy at Twitter started to do automated deployment, push a button, and that was like 2009-ish. And so the first, I think, DevOps meetup was around then.
Hmm.
So it's been
Yeah,
15 years, I guess, 16 years.
because like I was trying to, so I started my career in 2010. So my first job was as a Java developer. And like I remember for some things, like we would just SFTP to the machine and then put the jar archive there and then like keep our fingers crossed that it doesn't break. Like it was not really DevOps. I wouldn't call it this way, right?
You were deploying. You
Yeah,
had a deployment process. I put it
yeah,
out there.
yeah, right.
Was that so? That was documented too. It was like put the jar on production, cross your fingers.
I think there was like a page on some internal wiki, uh, yeah, that describes like with passwords and like what you should do.
Yeah, that was, and I think what's interesting is why that changed, right? And we laugh at it now, but that was why didn't you invest in automating deployment or a whole bunch of automated regression tests, right? That would run because I think in software now that would be rare that people wouldn't
Want to have
use
that, right? Yeah.
yeah CI and CD. They wouldn't have some automated tests, functional regression tests. That would be the exception, whereas that was the norm at the beginning of
Yeah.
your career. And so that's what's interesting. And I think if we talk about what's changed in the last 2-3 years, I think it is getting more standard. There's a lot more companies who are talking data ops or data observability. There's a lot more tools a lot more people are using Git in data and analytics than ever before, I think, thanks to DBT. And there's a lot of tools that are, I think, getting more code centric, right? That they're not treating their configuration like a black box. There's several BI tools that tout the fact that they're Git centric, and that they're testable and
Mhm.
that they have APIs. So things like that. I think people are getting it.
Maybe let's take a step back and just do a quick summary of what DataOps is, and then we can talk about like what changed in the last 2 years.
Sure. So I guess it starts with a problem, and that it sort of admits some dark things about data and analytics, and that we're not really successful and we're not really happy. And if you look at the statistics on sort of projects and problems and even the psychology, like I think about a year or two, we did a survey of data engineers, 700 data engineers, and 78% of them wanted their job to come with a therapist, and 50% were thinking of leaving the career altogether. And so why is everyone sort of unhappy? Well, I think what happens is teams either fall into two buckets. They're sort of heroic teams who are they're working night and day, they're trying really hard for their customer, and then they get burnt out and then they quit, honestly. And then the second team have wrapped their projects up in so much process and proceduralism and steps that doing anything is sort of so slow and boring that they again leave in frustration, or live in cynicism, and
So
that
like the only outcome is quit and start woodworking.
yeah, the only outcome really is quit and start working. And um, as a manager, I always hated that, right? Because when your team is either full of heroes or proceduralism, you always have people who have the whole system in their head. They're certainly key people. And then when they leave, they take all that knowledge with them. And then that creates a bottleneck. And so both of which aren't, and I think the main idea of data ops is there's a balance between fear and heroism that you can live. You don't have to be fearful 95% of the time. Maybe 1 or 2% is good to be fearful, and you don't have to be a hero. Maybe 1 or 2% it's good to be a hero, but there's a
Mhm,
balance. And in that balance, you actually are much more productive as a team.
mhm. And fear is maybe like if I go back to my example of SSH and SFTP to like a production machine and then uploading the jar file and then keeping my fingers crossed, that would be the fear part, right? So
Yeah,
like
that would be, yeah.
maybe I shouldn't deploy it today because like I'm not really sure like if it will work fine or not, right? That's the fear.
Yeah, I think teams who have a lot of fear, what they do is they have checklists and then they have reviews and they have And so heroic teams will like, oh, go make the change and then hope it'll
Everything
work.
will be fine. Don't
It'll
worry.
be fine. It'll be fine. You're a hero. If it breaks, you're gonna call up and fix it right away, aren't you? That's the assumption. Is like it doesn't matter if it's Saturday, it's your kid's birthday party. Like I've talked to people at conferences where a guy was fixing a problem in data sitting on the toilet during his kid's birthday party. And like that's a hero. That's a hero. And it's good that he's doing that, but on the other hand, that should be the exception, right? You should that should be. And as a manager, I had to learn to sort of praise that behavior in public, and then in private say, well, how can we never have this happen again? I don't want you on Saturday fixing bugs. Like how can we find that bug before you deploy? And how can we do that in a way that's repeatable and automated?
So DataOps is a bunch of processes and procedures and tools that help us move without fear, right? And what was the
Move
second
without
thing?
fear. Yeah, it helps.
And also, like, don't be a hero, right? Don't fix the things on Saturday.
Yeah. Yeah, I think that's emotionally where it works to be. It's really about, from a concrete standpoint, it's about the reduction of errors in production. So, and errors could be caused from you've got some bad data, or somebody introduced some new code that you didn't know about, or a server went down, or you're late. There's lots of sources of error in production, and trying to drive the rate of errors down in production. That's one part of it.
So it's automation, thorough testing, things
Well,
like that.
I think it's observability,
Observability.
monitoring, um, uh, data quality in production. A lot of those ideas are in there, and the reduction of error. I think the second part is this notion of cycle time, which is how fast you can change something. And so the real benefit of cycle time, I think, is the increase in the rate of learning of your teams and the maximizing of the work that you do not have to do. And so what happens with teams who are fearful is they spend 3 months building something. They talk to the customer says, well, they hear the customer says, I want 10 things. So they go and build those 10 things, and then they present it to the customer, and the customer says, great, 4 of those are valuable, but you know what? I don't need 6. And by the way, here's another 10 things you should do. And so what happens is you get this waste, right? You have an error in production, well, you have to fix it, and sometimes emergency fix it. That's time that's wasted. You've built something that you think is right, but not as right. You've wasted time. And so by focusing on cycle time and error rate, you take out waste, and you improve your relations with your customer. And so that leads to really huge productivity gains. And in the last, a year ago, Gartner put a report saying teams who use DataOps tools and follow DataOps processes are 10 times more productive. And actually, I've seen that, right? They are just much more productive because of the fact that they've invested in testing and observability and deployment and source control, a bunch of technical things.
And so we started talking about what has changed in the last 2 years. And to me, what changed is like if you look from all the ops, ML ops, DevOps, LLM ops, something else ops, over the last, I don't know, 5 years. So there was a rise of ML ops, and it was quite, there was a lot of hype around that. And to me, because of that, I started to notice other opses like DataOps, for example. So for me, I only found out about DataOps because MLOps was a thing everyone was talking about, and then it was interesting. Like, okay, what are the other things that are also useful? But now with MLOps, like there is much less hype there, right? So because now the new hype is in AI and AI ops, whatever, like LLM ops, and to me it feels like I don't see much data ops these days on social media, on podcasts, on conferences. Like people talk these days, like 2 years ago, people were talking about ML ops. These days, I only, not only, but mostly see LLMs, AI, all these things. And to me, it feels like, well, people don't talk about data ops. Maybe nothing is really happening there. And I'm sure this is not the case. Like, so what actually happened in the last 2 years? You started talking about
Yeah,
like,
we could talk about the last 2 years. So
yeah,
let me talk about terms and tech. And
yeah,
so I'm an engineer and I like well-defined terms because I think it helps. And so we spent a lot of time having a definition of ops, data ops. And I think the definition of data ops is a ripoff of principles that were created by people who were working in the Toyota factory, 50, 80 years ago. It's,
where?
lean,
Which factory?
the Toyota
Uh-huh.
car
Okay.
factories, like lean techniques,
Hmm.
total quality management, um, Deming, those ideas on how to run a factory, they've been around for 50, 70 years. And then this idea of how to make changes to software, the idea of automation and DevOps, they've been around for over 15 years, maybe 20 years, right? But on some counts. So these ideas are there. And you use the term ops, LLM
Hmm.
ops. And so applying them to data ops, I think, whether you call it data ops or model ops or LLM ops, they're kind of the same idea, right?
Hmm.
And it's just, and they're all sort of based in the same intellectual history. So that's one thing. Second is the pollution in tech terms is so, the marketing people get a hold of any term,
Hmm.
and then basically they'll write a white paper saying, insert latest buzzword here, definition,
Adopt.
and then our stuff. And
Uh-huh.
there'll be a
Okay.
paragraph saying that says in the middle says, in order for you to do that cool buzzword, you got to buy our stuff.
Of
Like,
course.
and like I read these things and I'm like, that the front has nothing to do with the back.
Hmm.
And so what happens is terms are really distorted. And
Hmm.
like all these ops terms, and it happened, and there's been more what I consider crossover terms from software, like data mesh or data products or data observability. All these terms are really crossed over from original software ideas
Hmm.
and have kind of, they're starting to lose their meaning, right?
Hmm.
Like data mesh was domain driven design,
Hmm.
but it also had this term of data products in, which to me, data products is about a process methodology, not about a thing. And so, I think I don't think we do a service to anyone in the industry by distorting all these terms. I think we should stick to them in a more precise engineering way. Um, and people should be upset every time. But we keep doing it. Right now it's lake house, right? And like it's so these everyone wants to implement the latest thing, data product, lake house, data mesh, and then 2 years it'll be another set of terms. And it doesn't really do our industry any service. And so you got to look at what the core ideas are. And so to me, there's a core ops set of related ideas around agility and thinking in systems that I think we need to work on. And whether it's a large language model or a data science model or data, it doesn't really matter. The principles are the same.
So I like the term you just used, core ops, which is like anything ops, right?
Yep.
Where the agility is one thing, is like moving in small steps and then like seeing what happens, being agile, right? And then the other part you mentioned was thinking in systems.
Yeah.
What exactly does this mean? Like, what does it mean to think in systems?
Um, well, I think we focus a lot in data and analytic teams on the day one problem. I've got a customer, I've got to build something for them to solve their problems. And you have a day two problem. Once you've done that, I want to run that with new data in it on the second day. And how do I know, metaphorically, if day two is going to work right? Because people could give you new data. And then the day three problem is that customer is going to change their mind and want something more. And so the systems to focus, we focus a lot on day one, but day two and day three, monitoring something for low errors, changing something quickly with low risk, those systemic tasks need to be done. And in some ways, you need to build a system around, next to, or around, or supporting your day one work to do that. And so, and it's hard for people in data and analytics because functionally, a lot of times people are, I'm a data scientist. I work in Python. I get my data from someone else. I deliver my model to someone else. Data people are, I'm an ingest person, or I'm an analytic engineer, or I'm a BI person. Our roles are very separate. And so that also hurts when people don't think in systems because, I think did that answer your question?
Uh, Partly, I'm
Yeah.
still a bit ambiguous. So let's talk about this data scientist, right? The data scientist wants to pull data from one data source, process it in some way, create a machine learning model or some prediction or some analysis, right? And then like there is some artifact at the end, right? So there is some pipeline that they create, right? And the data comes from some, I don't know, data lake or data warehouse that some data engineers put there. So in this case, day one problem would be, I guess, helping this data scientist or like somehow figure out like what exactly they need or
I think the day one problem is the data scientist doing, pulling the data, doing the transformation and building the model and getting it ready, saying, here, I've done my job. We have the
and
prediction.
here's this Jupyter notebook, right?
Here's
With
this notebook,
okay,
and
yeah.
my job's done,
Uh-huh.
right? And then okay, the, every data scientist is really interested in the next Jupyter notebook.
Mhm.
They're not really interested in the last 5 or 10 that they did. And so the day two problem is you've got to take those Jupyter notebooks and insert them into a system where they can run easily, and they can tell you if they got bad data going into it. They can tell you if the prediction's wrong. So someone can then run that Jupyter notebook day in and day out and not have to have the brain of a data scientist, right? Um, and then second is like you want to hire a 23-year-old into your team. And when there's a bug in that notebook, you want to take that 23-year-old who has a master's or a bachelor's in CS, and him or her is really smart. They know Jupyter notebooks, but they don't know anything about your company, your data, your environment. You want them to be able to go in and fix a bug, change one line of code, and then be able to deploy that change with really high confidence that is not going to break something for the customer. Or sometimes notebooks are used as interim points in, maybe there's a visualization, or maybe there's an export, or maybe there's some other process.
Mhm.
And so how do you take a 23-year-old who's really smart, really loves data, and but they don't understand all the complexities of your environment?
Like there
How
could
can,
be Kubernetes, right? There could be some other thing, right? God
yeah,
knows
yeah.
what.
How can you
And
give them a button?
yeah.
And this, so you have a son. So I have a son. When he was 23, he got a degree in computer science. Surprise. And he was a typical son of a nerd father. His room was covered in Legos when he was 8, like a mess. And then when he was 16, it was covered in something that I don't know what. And so he got this job at 23 at Amazon, working on business to business transactions, right? And I'm proud of him. But like in his first week, he made a code change and deployed it to production. And I'm like,
Amazon,
there's no,
which is
there's
a
no,
gigantic company, right?
yeah, it's a jig, and it's business transactions, and like I wouldn't trust my son to do that. I mean, I love my son, but I would not trust him to do that. And so what did they do? They had a system next to my son that said, 23-year-old, you made a change, your one line code change, big red light, you broke something, right?
Mm-hmm.
And that's what we need. We need to be able to inject 23-year-olds into our company who can make small changes with a big right. And that's a systems problem. We need a system to do that. And I think that's and actually good software development teams benchmarks themselves on that. You know, can we hire someone that can fix a bug and deploy to production in the first week? And what's underneath that, they do that with a lot of automation and deployment, a lot of testing, regression, functional testing, to make sure that that happens. I mean, any company can have a 23-year-old deploy something, right? But it's deployed with knowing that it's going to work.
Yeah, right. So here, thinking in systems means you need to have a platform with all the bells and whistles, like the regression test component, the automatic deployment component, whatever component, right, which are there. They are integrated to your platform, and then all you need to do, or all this 23 years old needs to do, is just do a little tweak, press a button, or I don't know, execute a command, and then like it goes through all this set of systems,
Yeah,
and then there is confidence that this thing, like it either breaks in the middle, and we see okay something is wrong, and it doesn't reach production, or if it reaches production, then it's good.
exactly. Yeah, I think that's really it. It's like just find problems before they reach to production, right? And we can talk a lot about how you do that, but that involves number one, sort of the railroad tracks to move something from development to production, and then signals on those railroad tracks to tell you if something's wrong. And those are usually based on tests, based on infrastructure as code, based on using version control, based on having good test data that's reflective of customers. And just that act is like, if you can deploy quickly with low risk, if you can plug in a 23-year-old, you're then much more likely to say, no, you're much more likely not to say, it's going to take me 3 months to get something done. You'll say, I want to do this in a week, and I'll get you one of your requirements, and we'll take a look at it and see if you really need this. And then they'll go, oh, you know what? I don't really need this. You're right. And then all that 3 months of work you just saved
Mm-hmm. Yeah.
because you've gotten something earlier. And I guess I've gotten very humble about what I think I know customers want, and giving them a little bit, giving them something 70% right that's imperfect, and getting it early to them is so much better than sitting back. And you know, we all love to code, right? I'd love to code for 3 months and not have to interact with anyone, but like, and I've done that, but it's just you get it wrong.
Mm-hmm.
And so I think that's and then there's, you know, the similar problem of you have something in production and your data provider's giving you some weird data, right? That they've changed the data. And how can that, or Docker Hub we've had some problems with Docker Hub not deploying images, or you know, something has gone wrong on one of your servers, is running out of memory. How can you know these things before your customer says, hey, the report's blank, or hey, these numbers look funny?
Mm-hmm.
And I think that's similar. It's sort of it's the opposite part. We call it the top of the T versus the bottom of the T.
Mm-hmm.
You know, the production versus deployment.
Mm-hmm. And one of the things you said, like when you try to understand what the customer wants, you already know that it will be very hard to actually know what they want 100% correct. You'll spend a lot of time, and probably you will not actually have what they want. So it's better to ship something that is 70% correct, but early, quickly, and then start getting feedback. So I was wondering what tools now we have in place that that we started using, tools and processes that we started using over the last 2 years that support rolling out something quickly, this 70%, right? So you started talking about more DBT, right? So more and more teams start using DBT. There is more focus on Git and even more focus on observability. So I think when I was exploring the DataOps part 2 years ago, there was a lot of talks around data observability. So it was already quite part of the ops part. There were many tools around that. But yeah, so I'm wondering what exactly is new now these days. Like, did it change the way we do things, or it's mostly the same? It's just becoming more mature.
I don't know. I've been saying basically the same thing for a decade.
Okay.
And so it's, to be honest, it's slower than I would like on the adoption. And it really, and on my definition, it doesn't matter if it's a data process or a visualization process or a model process or an LLM deployment. The principles all apply and the ideas are there. And so I think it's getting better and worse at the same time. And so I find that people are starting to use, like, I would talk at conferences a decade ago and ask people how many people knew what Git was. And literally 1 out of 100 would know what Git was. And
10
so
years
now
ago,
people are
it was
using,
like analytics analysts.
yeah, this was people who were in data engineer and data analyst roles.
Uh-huh. Okay. Interesting.
So,
So they
so
use Mercurial or SVN or what?
yeah, I had a slide in a deck. I had to explain what Git was and
Okay.
why you wanted to use it. And
Because like
and so,
GitHub was already quite popular back then, right?
oh, Git was, yeah, and Git, it's not Git. I just said version control, whether it
Uh-huh.
was like
Okay.
SVN or CVS or even the old style Gits. I think it's and why was that? Well, most data people were using GUI based tools to do their work because
Mhm.
the data career,
Like Informatica, right? This sort of stuff.
Informatica, which is, it does sort of version control, but it's not really code, so it's really hard to diff. When more
Yeah,
than
right.
one person. Um,
Or
and so
this Microsoft integration service, right?
yeah, like SSIS.
Yeah.
I mean, you can all persist workflows to something, but they're very hard to read. And so, if anything, what DBT brought us is a legible way to store your data integration code. And the same thing with Airflow. It's code, right? And then there's, because I wrote the manifesto, and one of the things is analytics is code.
Mhm.
And that's the intellectual property that your organization is creating, is code or configuration. And that code should be in Git and
Mhm.
stored and versioned. And I think, so what's kind of happened in the last 2 years, I think it's going slower than I'd like. I still think there's a lot of heroism. I still think, maybe I'm a little surprised how much, because it happened in you don't run a factory today without using Toyota and lean manufacturing techniques. You don't run a software project without doing DevOps and Agile. But lots of people start and continue to do data and analytics projects where they throw a bunch of stuff up in production and kind of hope it works. And so to me, I guess I'm perplexed as to why it's taking longer than I thought it would, to be honest. And
Because like everyone is busy using ChatGPT, right?
yeah, everyone's busy. Everyone focuses on day one. I mean,
Yeah, right.
what does an LLM do? It
Mhm.
generates things for you. And so it's great. You can go into, you can open up Azure and you got all these icons and you can generate a lot of things. It's cool. There's all sorts
Yeah.
of tools to generate things. And look what I did. I built, I built a predictive model, or look what I did. I built a dashboard. Or look what I did. I used ChatGPT to help me write some ETL code.
Mhm.
Fantastic.
Yeah.
If 70% of data and analytic team time is wasted, we're focused on 30% where it doesn't matter. The incremental margin of improvement on 30% is, even if you increase everyone's productivity by 20%, you still haven't made a dent in the overall problem. 70% of the time in data teams is waste. Focus on the waste. That's where you're gonna drive productivity.
So, like, I am a bit lost, like here with 70, 30%. So what you're saying is, let's take an analytics team. So what they do 70% of the time is going to end nowhere, right? So it's going to be waste, right? And only 30% of what they produce is actually going to be used by, I don't know, business customers, whatever. Is this what you say?
Yeah. If you look at their daily time, right? The time, like I'm on a keyboard, I'm creating something and building something. 30% is generous in that amount of time. We've had customers, and well, sort of like Harvinder Atwal, who's a CDO and wrote a book on DataOps. He did surveys of his team, and he found it to be 15% of the time people were actually doing something.
Mm-hmm.
And the other sort of 85%, well, they were in meetings. They were reworking something that's in production. They were waiting on someone else, right? They were fixing something that was broken already. And so and this sort of time is not what we love. Like the reason, we've been given these gifts to be able to create and code and do analytics is that not everyone can do it, right? It's nice that we have these weird gifts. 5-10% of the population is really good at it. And so most data and analytic peoples can't join the Olympics and, run a sprint, but we can code, we can think. And so I like to do that. And I would rather not fix something that's broken. I would rather not, like, we have war rooms when something goes wrong, and we all meet and fix it. That's just wasted time. So I think, to me, the big gains is to focus on the waste and decrease the waste and increase the funds.
Yeah, and how does DataOps help? So DataOps is processes, right? Tools, processes, and mainly processes, how exactly you work. So how does DataOps, what kind of processes from DataOps can help us reduce this waste? Like, can't we just say, okay, like now I stick to DataOps principles, so I'm not attending any meetings? Why?
Maybe, yeah. I mean, that happened in software, and yeah, you have these sort of fake agile projects, right? Where they do dev sprint, dev sprint, dev sprint, QA sprint, QA. They follow all the rituals, but they miss the entire point of it. And so it is a culture change. However, I think, how can you get something 70% right? How can you have a 23-year-old make a small change and get it into production with confidence? Like those, if you start thinking about it, there's a couple of tasks that you need to do. One is you need to be able to use automate deployment with scripts or CI and CD. And so you need to say, okay, and use version control. So I've used version control, and I've automated a way to deploy, and then you need tests that run in development before production. And sometimes there's different classifications of those tests. Sometimes they're called unit tests. Other times they're called impact tests. Or what you don't want to do is have someone who knows your data eye it up and say, oh, this looks right. You want to have it scripted and
Does it
automated.
still happen?
It happens all the time. In fact, that's
Okay.
the majority of the way people do it.
So I probably live in a bubble. Because like to me, what you say sounds like common sense. Like, why wouldn't you not have CI/CD these days? Like, it's not 2010. 10 right now, right? Like you have all these GitHub actions, GitLab CI/CD, GitHub actions, like even Jenkins, whatever, right? Like, why would you not use Git? Why, like, why would you not have a dev
Well,
environment?
there's degrees. So some people will use Git, but they'll use Git and they'll use GitHub Actions, but they won't, and they'll have a unit test or two. And so they'll say, okay, we're doing this, and then they still find problems. Well,
Mhm,
unit tests, even if you do all that, unit tests are meant to be quick checks,
mhm,
but they're not. You need to have functional test, end-to-end
mhm,
tests. You need to pour test data into your system and run it. And so it's that's also part of it. And then also because teams are so largely separate, maybe the data engineers do it, but the data scientists don't.
mhm.
And so you deploy your ETL code,
Right.
but the data scientist code is up there and Databricks putting their notebook into production by flicking a switch. And the same thing
Mhm,
with Tableau. They hit it in production through the UI. And
mhm,
so it's not done end to end. Maybe there's pockets of it, but people who come from the software world where this is somehow taught, and I think software engineers are very judgmental, and they'll look at stuff and go, ew, that's disgusting. And they'll like really go, ugh, like you just did. You went, ugh. And like I think we need to do that more as data analytics teams go, you're doing what? Ew.
mhm. So judge more, like judge people more
I
is
think,
what?
yeah, we need to be judged. We don't need to judge people, but judge the systems in which they,
Sorry, judge the code.
yeah.
Well, I remember once, so I joined the team and then I said, yeah, like, what kind of code is that? Like, who even thought of writing this? And then, of course, the person who wrote was in the same chat. And then the manager approached me saying, like, hey, don't, this is rude. Don't say that.
Yeah, yeah. Well, you've got to find the business way to say,
Yeah,
uh, which is instead of saying, oh, you say, well, I think there's opportunities for us to improve this
right,
code.
right, right. But yeah, I was young, and how do you call these people who are like my favorite book was Clean Code, and like if something was not following the principles from this book was like, "Ah, now I'm much more pragmatic, and it's okay for me to have like a two-screen function, right? But like back then it was like, oh,
I know,
and
I
like
know.
people didn't like when I was expressing my opinion about their code.
Yeah, yeah. Well, there's when you get older, you find business euphemisms to say oh.
Yeah, right. So,
But
anyways,
I think
yeah.
it's still I, I something is we've accepted the chaos as a data. We're more inclined to think that this stuff doesn't apply to us or data is an exception. Um, or I don't know, like to me, this stuff, I feel the same way. It makes total sense, right? Don't run your production systems without checking that the input data is good or checking
Mhm,
that the output data is good. Like
mhm,
just know if there's problems before your customer sees them.
mhm.
And so what
And
happened to us as a company is we focused for many years on trying to help people deploy faster. So
mhm,
we built software and tools on trying to kind of help in the development process first.
mhm,
Say, if you put something in this, you'll see the change right away.
mhm,
And we had integrations and tools, and what I found was almost everyone would open up AWS and start building, and then they had stuff in production, and it was too hard to retrofit all the stuff that they already built when they weren't using Git or version control, and it was too hard to find people who were starting early. And so about 2.5 years ago, we realized that the best place to start for most teams is in production,
mhm,
is to start and to start observing the production systems. And then for us, the second thing that we learned was that I thought I had gone to 6 or 7 years ago, I went to the DevOps Enterprise Summit in Las Vegas. It's the Gene, Gene Kim, the guy who wrote the Phoenix Project. It's a conference for enterprises who are trying to adopt DevOps principles. And it's really good. People are really joyful. They do presentations and they talk about how to get their teams to adopt Agile and DevOps. And I'm like, oh, we're going to do that. That's what's going to happen. At some point, data and analytic teams are going to say, we're going to need to adopt DevOps or DataOps or whatever ops term you want to use. And we're going to have a conference. And so you should get the senior most leader involved. So we spent a lot of time talking to chief data officers and trying to educate them. It turns out that the average life of an employment of a chief data officer is like 2 years. And they get fired so quickly that like they can't make any changes.
They don't leave voluntarily.
Yeah, they don't leave voluntarily. They're quitting because it's there's such a mess out there. And so they get in and they come in and saying, we're going to do insert Gartner buzzword 1, 2, 3. And then they find out they can't run, they don't know how many pipelines they're running. They can't tell if things are breaking. Their customers are unhappy. Their data teams are inward focused and process living in a fearful way. And they can't do anything. And so then they get frustrated, they quit. And so what we've decided is to focus on, instead of focusing on development, we're focusing on production as the place to start. Instead of focusing on chief data officers, we're focusing on individual contributors. And so that we've also, from our standpoint, we've always been a profitable company. We've never had investors. So we spent millions of dollars building new products that we've completely open sourced, Apache 2 open source. And the challenge that so let's say you're an individual contributor data engineer on a data team. You hear this and you say, oh, this sounds good. And what do I do next? Well, I think the first thing that you do as a data engineer is you add data quality validation tests. You test your data. You check, and that's actually a little hard to do because A, most data engineers are very busy, and B, they don't have like the context of the business. So we wrote an engine to scan your data, use some smarts, a little AI and algorithms to automatically build data quality validation tests for data engineers. So that way.
And you'll send us a link for us to read more.
Sure, it's on Git, yeah.
Questions that before we finish, maybe we can answer. So the first question is, how important is learning Kubernetes? Has industry adopted it yet? Well, I think it is, but like, maybe.
Yeah, it's probably important, but I hate Kubernetes. God, I hate Kubernetes. It's so complicated. Okay, you probably should learn Kubernetes because people do it. But you should also say, if your team is like 2 or 3 people, do you really need Kubernetes? Can't you just run something on a Linux system? And so like Kubernetes is very good if you are going to run hundreds of processes. If you're going to run 10 processes, you probably don't need Kubernetes. So it is good to learn.
Yeah. And
Docker. Learn Docker first, then Kubernetes.
Yeah, because like the question was not over. There are a bunch of questions in one. So we'll just know in traditional VMs technologies. I assume this is like Docker. Is it sufficient? And this is what you just said, like just learn that. And then like maybe instead of using Kubernetes, there will be something else, maybe something lightweight, or I know there are so many alternatives these days in the cloud, right?
There's other ones. There's Docker
like Google Cloud Run or like ECS or whatever.
There's like Elastic, there's Kubernetes, there's learning Kubernetes, the ins and outs, and then there's being a user of Kubernetes, right?
Yeah, right.
To be a user of Kubernetes, don't learn to be a DevOps engineer of Kubernetes.
Yeah.
I'm interested.
I remember I was speaking, so the problem I had was as a data scientist, when I wanted to deploy something, I needed to use Kubernetes for that, right? And like we didn't really have, like it's not something data scientists would do typically, but I needed to deploy something, and then platform engineers were always busy. So I then spoke with one of the platform engineers saying like, look, you're always busy. Just teach me how to use Kubernetes. And then what he said, just install Minikube on your machine. Try to play with this, and then like you'll figure it out. And this was a great piece of advice because like it took me just a couple of days to figure it out. And now with ChatGPT, and now you have Kind, which is Kubernetes and Docker, which is like even lighter weight version of like Minikube, not version, but like lighter weight Kubernetes that you can just deploy locally. Yeah,
Yeah.
like
Yeah, yeah.
you
Like
need
I
just a
can
couple of days.
running on my desktop, and I think what's interesting is you said there was a platform engineer, right? So there's somebody was in charge of your team of
Kubernetes,
making
yeah,
sure that things deploy, and
yeah.
I think data and analytic teams need to have someone because
Mhm.
like data people are interested in the nuggets of cool code that they've created, a model, a visualization, a transformation, an ingestion. They're really, and somebody's got to take those nuggets of cool code and build the system around it, build the platform around it.
Yeah,
And so
that is
that's what I'm talking about
correct.
is like who does that role? Well, it's a
Mhm.
platform engineer, it's an SRE, it's a DevOps engineer. We have different
Yeah.
terms in software, but we need to assign someone to do that and not just, you know, in data and analytics world.
hmm Okay. Yeah, that's a very useful role, very useful profile. So another question, how data is versioned in the industry these days? Which tools, methodologies are used, and what is your advice regarding that?
Okay, my advice is not to version data, but to
Okay.
version the code that's acting upon data. I don't think data needs to be versioned. I'm a more and so why is that? Because the processes that act upon data are more important than the data itself.
hmm
And so I tend to think you should have, because storage is cheap, you should have immutable data sources. So every time you get data, you never change it. And so I'm a fan of idempotency and functional
hmm
programming. And so from a design standpoint, I like that. So I don't believe in versioning data. I believe in immutable data with functional ways to access it. And I'm a big believer in versioning the processes that act on the data because code's more important than data.
Actually, which reminds me of functional programming. In functional programming, immutability is a big thing because
Yeah,
when your data is immutable, like all of the concurrency issues go away, right? And here it's the same, right? So like you just know which, well, it's still kind of version you have, right? If your
I
data
think
is immutable, you need to know like how exactly to refer to this particular
exactly.
state of data.
Yeah, yeah. It's not literally versioned, but like, yeah, you have to. It's time-based versioning or something. You know, at this
It's
time
like
and
Delta Lake is one of those things that do it, right? Or
data. I think a
some,
data. Yeah, you could say a data lake sometimes is like that. It depends on your version of the term, but like,
there are some technologies that are immutable inside, but it doesn't look like that outside.
yeah,
Like they are
I'm
project-based,
not
I think.
aware of that. Yeah, I
Yeah,
mean,
I
to
don't
me,
remember the name.
I guess I
Anyways,
just think of like putting it in the bucket store and
okay.
not changing it.
Yeah. Right. Question from Adonis. Shouldn't the quitting teams cure be in the mindset and culture rather than tooling and data ops?
Yes,
Yeah.
yes, it is. It's both, and that's the hard
But data
part.
ops is also cultural, right?
Well, I believe so. Yeah, um, I think the culture has to come from the team saying enough is enough. I'm sick of quitting every 18 months. I'm sick of being unhappy. I'm sick of my customers looking at me funny because I'm going too slow. Right. And I think, and I'm sick of hiding from customers. I want to be involved with customers and deliver value. And so I think that is it's just it's a better way to work. And I think it is a cultural change. And I think it has to come from the bottom because the people at the top are only going to be there for 18, 24 months before they get fired.
Well, hopefully not everyone is changing jobs that quickly. Because like if everyone is just is not there already in a year, then like
Yep,
It's a
all of
problem,
it
right?
goes. I
Yeah.
know all of it. People build all the code, and that's yeah, and it's unfortunate that that happens, but you do get a lot of job hopping in data and analytics.
I mean, that's how it is these days, right?
Yeah,
Anyways,
if you've ever run a team and you've got
yeah,
that person who knows everything
yeah,
and they quit, it's
and that's
awful.
a problem. Yeah,
It's awful. Yeah.
yeah,
And then as a manager, I've done that. I've sort of like back 2006 and seven, I'm like begging that person to stay. And they're like, I'm really good. All I'm doing here is fixing broken stuff.
yeah.
I can get a new
I
job.
I
I can
was that
create.
person. Yeah, like not a fun like pastime, let's say.
It's not a fun time. Well, but the other hand, they created it, right?
Hmm.
They if you go ahead and you try to be a hero and you build all your this stuff that isn't automated and tested and deployable and version
Yeah.
control and all these things, you build. I think of it as like a cat, like a hairball. You
Hmm.
build a big hairball, and you're leaving that for other people. It's
Yeah.
not a good
But also sometimes you just stand near the person who builds it, and then that person leaves, and you kind of just, because you were looking over the shoulder, you kind of know what's happening there, and now all the knowledge about this tool is in you, and also about like other things, because like all the other people leave, and like all of a sudden you find yourself responsible for maintaining all these tools in 3 years, and like, okay, like, do I really want to stay here?
exactly. Then you're like, oh, there's another job. I make more money. Oh, the recruiter called. Yeah, I hear you. It's not it's not a unreason as an individual contributor. It's not unreasonable to have those thoughts. And I think whose fault is that? I think it's the leadership fault. I think the biggest cultural change is in the leaders of teams, and they have to realize that these things, like I did 15 in 2006, it's my fault, right? And so it's not. So what happened for me is I was reading this guy Deming, and he had this rule that said 96% of the problems in a factory are due to the processes in the factory and not the people. He called them special causes where people cause. Yeah, at 4% of the time, yeah, somebody screwed up or they're being an idiot. But 96% of the time, you haven't built the factory in the right way.
Hmm.
And if you take that to heart, like a lot of times when things go wrong, our first action as a leader is to find someone to blame and
Hmm.
fire. Heads will roll. And
Hmm.
really, what it means is when things go wrong as a leader, you haven't built the system around people. You haven't thought in systems. You haven't focused
Hmm.
on day two or day three. You haven't focused
Hmm.
on cycle time and error rates. And
Yeah.
that's really where I think the leadership needs. But I think the only way leadership is going to get there is if the individuals on the team start pulling them.
Yeah. So we can go on and talk about that for ages. And I think most of the questions we actually prepared and Johanna prepared for this interview, we didn't cover them because like we had so much fun talking about other things. So Christopher, thanks a lot for joining
Thank
us
you. Yeah.
today, for waking up at, what's what that, 6 a.m., right?
6 a.m., 6 a.m., which is hard for me. So feel sorry for me. It's like
Yeah.
my life
But
is,
thanks a lot. I
it's a real
appreciate that.
personal problem to have to get up at 6 a.m.
But you still like talking, even if it's early for you, and you shared so many things with us. So we appreciate that. Thanks a lot for joining us today. And also thanks everyone for joining us today too. So I see I wasn't really like I was so excited about talking, so I missed a few comments. But yeah, so thanks everyone for joining us today. Hope you had a lot of fun like me. And Christopher, looking forward to speaking with you again, maybe in a couple of years.
Yeah, thank
So
you for the opportunity. I enjoyed
yeah,
it as well.
be around and bye.